Introduction to radars, prepared by Abhishek Kumar and Akash Kesi. What is a radar? Radar stands for radio detection and ranging. Radar is an object detection system that uses radio waves to determine the range, angle, or velocity of objects. It can be used to detect aircrafts, ships, guided missiles, motor vehicles, weather formations, etc. Basic components of a radar: transceiver, antenna or scanner, and a display unit. This part consists of a transmitter and a receiver unit together known as a transceiver. The transmitter unit produces short duration, high power pulses of energy that are radiated by the antenna. They get reflected off the object and returned back to the receiver, thereby giving information about object's location and speed. Antenna. It is the most important part of the radar. It transfers the energy from the transmitter to the signals in the environment, which the required distribution and energy. Antenna is used to direct the radio energy in a given direction with high degree of accuracy. A radar display unit is an electronic device to present radar data to the operator. All the transmitted and received radio signals are converted into electronic signal of varying voltage, which is displayed to the user in the display unit. Basic principle of a radar working. The electronic principle on which radar operates is very similar to the principle of sound wave reflection. If you shout in the direction of the sound reflecting object, you will hear an echo. If you know the speed of sound in air, you can then estimate the distance and general direction of the object. The time required for an echo to return can be converted to distance if the velocity of the sound is known.
Radar uses electromagnetic energy pulses in a similar way. The radio frequency RF energy that is transmitted to and reflected from the reflecting object. A small portion of the reflected energy returns to the radar set. This returned energy is called an echo. Radar set uses this echo to determine the direction and the distance of the reflecting object. Role of the EM waves. A radar uses radio waves of the electromagnetic spectrum. Those waves have frequency ranging from 3 kHz to 300 GHz and wavelengths between 1 mm to 100 km. Like all other EM waves, the radio waves travel at the speed of light. The radiation field of an antenna is composed of electric and magnetic lines of force. These lines of force are always at right angles to each other. The electric field determines the direction of polarization of the wave. When a single wire antenna is used to extract energy from the passing radio wave, maximum pickup will result when the antenna is oriented in the same direction as the electric field. Now let us look at some of the applications of the radio waves. Um, the first use of the radar was for military purposes to locate ground as well as sea targets. This evolved in the civilian field into applications for aircraft, ships, and roads. In aviation, aircrafts are equipped with the radar devices that warn the aircraft of other obstacles approaching their path, display weather information, and give accurate altitude readings. Marine radars are used to measure the bearing and distance of ships to prevent collision with other ships and to navigate and fix their position at sea when within a given range. Meteorologists use radar to monitor precipitation and wind. It has become the primary tool for short-term weather forecasting and watching for severe weather such as thunderstorms, tornadoes, and cyclones, etc. Thank you for listening.